Okay, so we'll practice with some example about the construction of solution. This example here we have calculate the uh, calculate the mass percent of a solution containing 27.5 gram of ethanol and 175 milliliter of water. Assume that the density of water is 1 gram per ml. Okay, now don't forget the formula for the mass percent. So here, the mass percent, mass per mass, mass per mass, okay? It is the mass of solution divided by mass of solution. Be careful, guys. Here, mass of solute divided by mass of solution times 100. And here, we need the mass per volume. Will be also mass of solute divided by volume solution times 100. And also volume per volume percentage will be volume solute divided by volume solution. And also times 100. Now, always here when we have a solution, what does that mean? Solution, it will be the solute plus solvent. So if you have a mass of solution, you will add the mass of solute plus the mass of solvent to get the mass of solution. Now, don't forget, solute, it is the minor. It is the minor compound. Solvent, it is the major. Now, the common solvent also could be the water, but not always. Be careful. So this is something that will give you somehow to predict which one solute, which one solvent, and how you will deal with this type of question. Now let's go back to our question. What do we have? We have 27.5 gram ethanol. And here for the water, we have 175 milliliter, but this is volume, okay? And they are asking to calculate the mass percent, mass per mass percent, is this one. So we need the mass of solute and we need the mass of solution. Mass of solution equal the mass of solute plus solvent. Now here we don't have the mass of water, which is the solvent here, because it's the major. But what we have a volume, 175 milliliter volume. Now we can calculate the mass. We know that density equal mass divided by volume. So here mass will equal density times the volume. Density, it is 1 gram per milliliter times the volume, 175 milliliter. Cancel milliliter with a milliliter, and it will give you 175 gram. It is the water, the solvent. Now, here the mass divided by mass percent will be the mass of solute. So M solute divided by mass solution times 100. So here the mass of solute will be 27.5 gram ethanol, because it's the minor, so it will be the solute. Look at here, we have 27.5 gram 175 gram water. Which one is the major? Is the water. So water will be solvent. And this is the minor, ethanol will be solute. Okay, let's keep going. Now, here in the bottom, we have mass of solution, which is solute plus solvent. So it will be 27.5 plus 175 gram times 100. Now let's do the math. So here we have 27.5 plus 175. You will get 202 here. So here will be 202.5 gram. Now let's divide it. 27.5 divided by 202.5 times 100. You will get 13.58 or approximately 13.6% is the concentration of the solution. Okay, now let's look for this example. A soft drink contains 11.5% sucrose by mass. So mass per mass percent. What volume of the soft drink solution in milliliter containing 85.2 gram of sucrose? So here they need the volume of soft drink solution in milliliter containing this amount. Now assume the density of 1.04. So here they are asking for volume of soft solution. If we have the mass of solution, we will be able to use the density and calculate the volume. Remember, density equal mass per volume. So here, volume will equal mass divided by density. But I don't have the mass of solution here. Be careful, guys. Here, I have 85.2 gram sucrose, which is the solute. But also, I have this percentage, which I can use it as conversion factor. Now look at here, guys. This percentage, what we're learning from the lecture, 11.5%. What does that mean? It means the mass solute divided by mass solution. We can use this percentage as a conversion factor. Always mass of solution is 100 because we have it as a percentage. And here will be 11.5. So this mass of solute is represent the 11.5. Mass of solution will represent the 100. So we will use this as a conversion factor to calculate the mass of solution in this amount. Okay, so here we will have the 11.5% equal mass solute divided by mass. Let's start with the given information. The mass of solute. Here we have 85.2 gram sucrose, which is solute. Now times, how you will write down this conversion factor? We need to cancel. So I will flip it. So I will make it mass solution divided by mass solute, which it will give me here 100 divided by 11.5. So here I will put the 100 gram, by the way, this is a gram, this is a gram, 100 gram solution in the top, and here 11.5 gram solute. So here the solute is the sucrose, gram solute, the gram solute. Do the math and we will get here equal to, let's do the 85.2 divided by 11.5 times 100, give me 740.8. 740.8 gram solution. Now I get the gram of solution. What we're gonna do, I will use this formula. Volume will equal the mass divided by density. The mass here 740.8 gram divided by the density they give it to you, it is 1.04 gram per milliliter. That's a gram with a gram. Here, do the math, it will equal approximately 740.8 divided by 1.04, give you 112.3 milliliter solution. Don't forget this mass percentage, we can write it down as a conversion factor, and we can flip it depending how we need to cancel here the unwanted unit or unwanted mass or mole or whatever it is. Okay, let's keep going and practice with other example here. Okay, so calculate the mass percent of the sucrose solution contain 11.3 gram of sucrose and 412.1 milliliter of water. Assume the density of water, it is 1 gram per milliliter. Okay, so here we will be similar to the first question. So first of all, we need to find the mass percent here, mass per mass, which equal mass solute divided by mass solution times 100. Be careful, guys. Here, solution, not solvent. I have some students who it's confusing and they put the mass of solvent, but here it is solution. Okay. Now let's find the mass of water. Here we have 412 of water. Density equal mass per volume. Mass will equal density times the volume. Density here, it is 1 gram per milliliter times the volume, 412.1 milliliter. Cancel mil with the mil, and we will have 412.1 a gram. It is the mass of water. Now let's substitute it here. Don't forget the 11.3 gram is the minor, and here it is the major. So this one will be solvent, this one solute. It's very important to decide which one solute, which one solvent, because it will affect your calculation. Here, mass of solute will be 11.3 gram. Mass of solution will be 11.3 gram plus 412.1 gram. This is solvent. Be careful, guys. This is solute. Solution always equals solute plus solvent. Okay, now times 100. Let's do the math and let's see what we will get here. So we have 412 12.1 plus 11.3. So we will get here 123.4. Now let's divide the 11.3 divided by 123.4, and we will get this times 100 and give us 2.66. So here the percentage 2.667, 2.67% mass per mass. Okay. Calculate the molarity of a solution made by putting 15.5 gram NaCl into a beaker and adding water to make 1.5 liter of NaCl solution. Molarity. The molarity equal mole solute divided by volume solution, but in liter, supposed to be in liter. Now, it's better to do this diagram here. Let's deal with this. Molarity equal mole divided by volume in liter. Also, don't forget the relationship between mole and mass. Mole equal mass divided by molar mass. This is molar mass. Okay? Because in this type of calculation, usually we need, not always, most of the time we need both of these, depending on the type of the question that we have. Okay, let's start here. Molarity equal mole NaCl divided by volume solution in liter. Now the volume, we have it, but the mole, we don't have it. We have a mass here. So here we will use this formula to find the mole. So here, mole NaCl will equal what? Will equal mass NaCl divided by molar mass NaCl. The mass here, 15.5 gram NaCl. And let's do it this way, dimensional analysis. So do it here. The mass is 15.5 gram NaCl. And there's 1 mole in the top NaCl, and 23 plus 35.5, so it will be 58.5 gram NaCl is the molar mass. Now cancel gram NaCl with this one, divided the 15.5 divided by 58.5, and that will give you 2.6. It will give you 0.265 mole NaCl. Now let's go back to this equation. Here, molarity will equal the mole 0.265, and the volume, it is 1.5 mole. Here 1.50 liter. So here divided by 1.5, it will give us 1.77. Sorry, 0.177 approximately mole per liter. Now this, you can replace it with capital M. This is called molar. You can write it down as a capital M or mole per liter. It's up to you. Okay. Let's look at this question. calculate the molarity of a solution made by putting 55.8 gram NaNO3 into beaker and dilute it to 2.50 liter. Excuse me. The same thing, molarity, capital M, equal mole, solute, divided by volume, solution in liter. Now, mole solute, we don't have it. Let's calculate the mole. Here, mole, Na, mole will equal what? Will equal mass divided by molar mass. Now, we will have 55.8 gram NaNO3 times 1 mole in the top. Guys, because it's dividing, so you will make it the 1 mole in the top here. But if we have multiplying, you will put, if it's multiplying molar mass, in that situation, you will put the mass in top. Okay, 1 mole NaO3. Why I'm doing this? Because we need to cancel, to be able to cancel. Go see. Okay, what is the mass of NaNO3? So sodium 23 plus nitrogen 14 plus 3 times 16 for oxygen here 48 plus the 14 will give us 62 plus 23 will be 85. Just double check the number, guys, here. So here will be 85 gram NaNO3. Now look at here, I can cancel gram with gram. Okay, that's why I put the mole in the top. Do the math, 55.8 divided by 85, give me 0.65 or 0.66 approximately. So that will give you 0.66 mole. Now put this one here, so it will be 0.66 mole divided by volume of solution. It is already in liter. If it's not in liter, you have to convert it to liter. Sometimes they give it to you in a milliliter. So in that situation, you have to convert it to milliliter. Okay, here 2.50 liter. Now let's do the math. So let's divide it by 2.50, and we will get 2.26. So that will give me 0.26 mole per liter, or you can say 0.26 molar, capital M. Okay. Let's look to this example. How many liter of 0.114 molar sodium hydroxide NaOH solution contain 1.24 mole NaOH? We know molarity equal mole divided by volume per liter. So here they are asking for the volume. So volume will be mole divided by molarity. If you need to calculate mole, you will multiply molarity times the volume in liter. But here, you need to use this right now. So here, volume Okay, guys, be careful also. Sometimes they don't ask you what is the volume. They just ask you how many liter, how many milliliter. They asking about the unit. So they give you, sorry, a unit. So you have to understand that this is the volume what they are asking. So here volume will equal the mole divided by molarity. The mole here 1.24 mole, 1.24 mole. And here, the bottom, it will be the molarity, which is 0.114 mole divided by liter. So mole with a mole, do the math, 1.24. So 1.24 divided by 0.114 and give me 10.9, approximately 10.9 liter, 10.9 liter. Okay. Determine the molar concentration of Na positive ion and PO4 3 negative ion in 1.5 molar. Okay, so look at here, guys. Here, when we have this situation, look at here. How many sodium ion here we have? We have 3 Na positive and 1 PO4 3 negative. Simply, what you're going to do, the number of that ion, of each ion, you will multiply it by the concentration of the whole compound. The whole compound will multiply it by 1.5. So here, will be 3 times 1.5 and give you 4.5 molar. Here will be 1 times 1.5 and that give you 1.5 molar. So the concentration of sodium ion, so Na positive, will be 4.5 molar. PO4, 3 negative, will be 1.5. We will do the same things for the second question. Calcium 2 positive and Cl negative and 0.75 molar CaCl2. So here what do we have? 1 calcium and 2 Cl negative. So this one will be 1 times 0.75 molar, and that will give you 0.75 molar for the calcium. Here 2 times 0.775 molar, and that will give you 1.5 molar Cl negative ion. So Ca2 positive will be 0.75, sorry, here, 0.75 molar, and Cl negative will be 1.5 molar. That's how we will deal with this type of question to find the molarity or the concentration of a ion. Okay, let's look here at this question. To what volume should you dilute 0.100 liter of 50 molar NaOH solution to obtain 1.0 molar NaOH solution? So here we have the dilution. What will end? MV equal MV. This is before dilution, and here after dilution. Sometimes they use M1 V1 equal M2 V2. or M initial volume initial equal M final volume final. Okay, so let's look here what we have. We have at the beginning 0.1 liter, 15 molar. So these two will represent the stock solution. Then we have here 1 molar for the diluted solution. Here stock solution, that means the concentrated. Here the diluted solution. Okay, and V2 will be unknown. So M1 V1 equal M2 V2. Here the M1, it is 15 molar times the volume 0.1 liter equal the M2 1 molar times the V2 unknown, which is V2. Let's keep it V2. So V2 will equal here 15 molar times 0.1 divided by 1.0 molar, cancel molar with molar. And here we will have the V2, it is 1.5 liter. It is the V2. Okay. Let's look to this equation. How much 6 molar, 6 molar and a 3 solution should you use to make 0.585 liter of 1.2 molar NaNO3 solution. Then, so here M1 V1 equal M2 V2. So here the M1, here V2 M2. So how much? So they are asking for a V1. So M1 V1 equal M2 V2. So the M1, it is 6.0 molar. V1 is unknown. The M2 1.2 molar times the V2, which is 0.585 liter. V1 here will equal 1.2 molar times 0.585 liter divided by 6.0 molar. Cancel molar over molar. This is the math. So 1.2 times 0.585 divided by 6.0, we will get 0.117. 0.117 liter. Okay. Stoichiometry for the solution. Consider the precipitation reaction 2Ki. Okay, 2Ki plus ppNO3 give us PPI2 plus 2KNO3. How much 0.115 molar Ki solution in a liter, as they are asking for a volume, will completely precipitate the PP2 positive in 0.104 liter of 0.225 molar ppNO3 solution. Now, here, don't forget, first of all, we need the mole-to-mole ratio. We will use mole-to-mole ratio between which chemical? Between Ki and ppNO3. Now, how you will reach here? Molarity equal mole divided by volume. So here, molarity times the volume, ppNO3 by 2. And here, after you get the mole, they need volume. So here, volume will equal what? Will equal mole divided by molarity. Remember how to calculate the mole or volume. So here we will start from here. Molarity times the volume of ppNO3. We have molarity 0.225 molar, which is mole divided by liter by 1 liter times the volume. It is 0.104 liter, so I will cancel liter with liter here. Now, I get from this step the mole of ppNO3. Now, from here, I will use the mole-to-mole ratio between ppNO3 and Ki. So remember, here we have an ppNO3 by 2. So how you will write down the mole-to-mole ratio between ppNO3 and the Ki? There's 1 to 2. Here you will put the 2 mole Ki in the top, 1 mole ppNO3 by 2 in the bottom to cancel the mole of ppNO3. Now I have mole of Ki. I need the volume. Volume equal what? Equal the mole divided by molarity. You have the mole here in the top, so it will be times 1 divided by the molarity. What is the molarity of Ki? It is this one, which is 0.115 mole Ki divided by 1 liter. It's mole Ki. Mole Ki. Here our unit will be in liter. Now let's do it. So we have 0.225 times 0.104 times 2 divided by 0.115 and equal 0.406 or 0.407. Okay, so it will be 0.407 liter. Guys, just check the math after me. I'm just doing the math quickly. So just check also the math. 0.407 liter. Okay, let's look at this question. This is stoichiometry. How many milliliter of 0.11 molar Na2CO3 will completely react with the 27.2 milliliter molar HNO3 according to this reaction? So here we have the HNO3 plus Na2CO3 give me H2O plus 2NO3. Okay, so here also they are asking for the volume. They give you molarity. Of course, here start with the mole-to-mole ratio. Put it in the middle here. Mole Na2CO3 and mole HNO3. We need to reach here to get the mole-to-mole ratio. What they give you here, molarity times the volume in liter. Be careful, guys. Here, milliliter, so we will be converted to liter. And after you get the mole of HNO3, we will use the mole to mole ratio to get the mole of Na2CO3. Then they are asking how many liter the volume. Volume will equal mole divided by molarity. Okay, let's start it here. Molarity, it is 0.135 mole per liter times the volume after you convert it to liter will be 0.0272 liter. And that's a liter with this liter. Don't forget here we have the mole of what? Of H and O3. We are talking about H and O3. Now we need to use we reach to this point. Now I will use the mole to mole ratio between HNO3 in the bottom and Na2CO3 in the top. Here, from the balanced chemical equation, I have 2 for HNO3 and Na2CO3. 1 for Na2CO3. So 1 mole Na2CO3, here 2 mole HNO3. Cancel mole HNO3 with this one. Now I have the mole divided by molarity. So it will be times 1 divided by molarity, which is 0.112 mole divided by liter. Cancel mole. Here, don't forget Na2CO3. So this one. Do the math right now. So let's do the math here. We have 0.135 times 0.0272 and sorry, let's do it again. 0.135 times 0.0272. Now we will divide it by 2 divided by 0.112. We will get 0.16 liter. So here, 0.016 liter. Now look at here, guys. They are asking the volume in milliliter. So here you will multiply it by 1,000. We will get 16 milliliter. Okay. Calculate the freezing point of 1.7 molar ethylene glycol solution. Now, the delta T F equal molality times the K sub F. K sub F is 1.8, sorry. If we asking about the delta T sub B, will be molality times the K sub B, and K sub B will be 0.512. Molality, don't forget, it is the mole solute divided by kilogram solvent. That means the mass solvent in kilogram unit. So here represent the change. So this change. Now here, after you get the delta T sub F, it's supposed to be 0 minus the delta T sub F to get the freezing point. K sub B, boiling, elevation. So here it is the change, not the boiling point. So it's gonna be 100 minus, sorry, plus delta T sub B will represent the boiling point. Be careful what they are asking. Sometimes they ask you the change, so that's the answer. But if they ask you to a specific boiling point or freezing point, you have to do the situation. Okay, anyway, let's keep going working with this question. What do we have? We have delta T sub F, because it's a freezing point, molality times K sub F. Here, the molality 1.7 times the 1.8. Do the math, and you will get here 1.7 times 1.8. It will be 3.06 Celsius degree, but this is the change. This is the delta T sub F. Here, the freezing point will be 0 minus the 3.06, and it will give you minus 3.06 Celsius degree. Look to the boiling point. The same thing, delta T sub B, like molality times K sub B. And here molality, it is 1.7 times the 0.512. And let's do the math here. 1.7 times 0.512 and give you 0.87 Celsius degree. But this is the change. Be careful. The boiling point will be 100 plus 0.87, and that gives you 100.87 Celsius degree. Be careful with the boiling addition. Here, with the freezing, subtraction, freezing. So be careful, guys. If they just ask you for the delta TF, change in the freezing point, or change in the boiling point, you will stop here, delta TB, and here, delta T. So be careful what they are asking.